Welcome everybody. This is first SDMX IO webinar for 2025. Please keep your microphones muted, and we'll have time for questions and answers at the end of the webinar. Feel free to raise your hand or post your questions in the chat. So today's webinar is an introduction to pysdmx, given by Javier Hernandez from Meaningful Data and Xavier Sosnowski from the BIS. This is the first of two pysdmx webinars, this one being oriented to data producers. The next webinar, to be scheduled later in the year, will be oriented to data consumers. For more information about pysdmx and SDMX.io, feel free to visit the SDMX.io website. So, Javier is the lead software engineer of SDMX services at Meaningful Data. Javier introduced tools based on the SDMX standard and the validation and transformation language on SDMX. Javier maintains the SDMX-on library, which is now being integrated into pysdmx based on Python and data libraries like pandas and numpy. On BTL, he's a member of the BTL task force and maintains the BTL engine, which is part of the BTL suite. Xavier has been working with SDMX since 2005. He has represented two sponsors, the BIS and the ECB, in the SDMX technical working group, and has led work on the SDMX REST API since its inception. At the moment, Xavier architects and implements distributed systems powered by SDMX. With that introduction, over to you guys.
Thank you very much, Brian. And hello everybody, and a warm welcome to this webinar about pysdmx. On my side, I'd like to call pysdmx a pragmatic and opinionated library because we think it offers a subset of the SDMX functionality in an easy, intuitive, and Pythonic way. So SDMX is a very rich standard, as we know, but sometimes it can be a bit overwhelming or seen by some as too complex. And what we really try to do with this library is to hide a lot of this complexity behind an intuitive Python API. And we hope you will agree with us at the end of this webinar. The project started at the BIS in the context of a new project we had, which is the Data Lakehouse project. And in this context, we needed to retrieve metadata from our registries. And Brian, there is some echo. I don't know if something can be done. Otherwise, I'll continue.
Cleaned it up. Should be okay now.
Thank you. So within the context of this Data Lakehouse project, we needed to implement statistical business processes such as data validation or data mapping. And these steps needed to be metadata driven. And so we needed to retrieve all the metadata we store in our registries, SDMX registries. This was to have an SDMX information model in Python, as well as different ways to retrieve the metadata. At the same time, we knew that our colleagues at Meaningful Data also had an open source Python library, but there the focus was a bit different. It was more on data. So we met and we all agreed that it would make sense to merge the two code bases because the emphasis on our side was on metadata, while the emphasis on Meaningful's data side was more on data. So it was really a good match. And this is how pysdmx was born. Now, pysdmx is part of Project Linkage X, which is the Swiss Army knife for SDMX in Python. And Project Linkage X itself is part of the BIS Open Tech, which is a platform for sharing statistical and financial software. So I hope this provides a bit of the context behind the project, but now let's go first to some interesting resources. The first resource is the repository on GitHub. And there, obviously, you will find the source code, as well as any changes we make to it in the forms of commits or the pull requests. And this is the case, obviously, for any open source project hosted on GitHub. But I think this is quite useful. Then another area I encourage you to visit is the discussions area. There you can ask any questions or suggest things, and we will try to reply as quickly as possible. Then another area of interest is the issue list. So in this issue list, in case there is a feature that you would like to see implemented but is not there available, feel free to capture it. If you encounter a bug, feel free to capture it as well, obviously, and we will try to work on these as quickly as possible. Now, it might also be interesting for you to go there to see what we are currently working on, because before we start working on something, we capture an issue here in this list, and then we create a branch to address that issue, and then later there is a pull request. So you will have the full traceability for any changes done to the code base, so full transparency. And these issues are organized in milestones. So let me show you that. If we go to the milestones here, you will see that one is closed, and that was for the first release, 1.0.0. But then we have already started planning the work for the next two releases. And if you go to one of them, for example, the next one, you see what we intend to deliver by the expected end date. So this gives you an idea about the roadmap. Talking about the roadmap, the focus now is on leveraging the upcoming SDMX discovery services to offer an intuitive way to retrieve data from various sources. So far, the focus was more on the data producer side, but with this, we will definitely switch towards serving the needs of the data consumers better. Another thing that we intend to work on is on allowing to use, so in pysdmx to maintain metadata. So far, the focus was primarily on metadata retrieval. But with this, then it will also be possible to maintain metadata in a registry. We will also make improvements to the different formats that we offer at the moment. Then this is primarily on the SDMX JSON side, and we will also add support for other formats that we at the moment do not yet support. Later on, we also intend to offer more like statistical business functions like data validation or data mapping, but this is for later, so it will not come at short or midterm. So for the repository, I think that's it on GitHub. Now, another area of interest possibly is the documentation, which is hosted on py.sdmx.io. And there, as for any software or library project, you will find the API reference, so all the functions that you can use as well as their parameters. But I think the most interesting part is probably all the tutorials that we offer and that are organized into three categories. One for metadata-driven processes, how to write them, basically. One about data discovery, that it's still at the beginning, because like I was mentioning, it's only now that we will really focus on the data consuming part, but still we have already some building blocks that can be useful. And then the other part is around handling SDMX datasets, like reading and writing different SDMX format messages, or using the VTL for validation. And in each of these tutorials, you will have information about the setup, the metadata required, and how you will have also some sample Python code on how to implement this. So just to give an example. I think this is hopefully sufficient as introduction. So let's start the hands-on part. And in the hands-on part, I will show you how to drive statistical processes in a metadata-driven way, while Javier will show you how to use SDMX to handle SDMX datasets. Before I show you the Python code, there is one more thing I would like to show you, and this is basically the metadata we store in Fusion Metadata Registry. And for this, we will use the FMR sandbox offered by the BIS on SDMX.io. So for those of you who are not familiar with it, the FMR is the reference implementation of the SDMX registry specification, and it's where you want to store all your metadata. It's used by the BIS, obviously, but also by other SDMX sponsors and international organizations. It's also used by central banks, statistical office, and other types of organizations. So it's quite popular, and it's also the software that has been selected by the SDMX Technical Working Group to power the SDMX Global Registry. So if you need to store statistical metadata, this is the place. Now, having a look at the metadata, you see a lot of different types of metadata that are available on the left-hand side. But maybe let's start with the ones that most of us are familiar with, which means the metadata that we use to define the expected structure of data. So kind of what we would call in IT a schema. And for this, let's use the consolidated banking statistics from the BIS. And if you go there, you will see the list of concepts that are considered relevant in the context of this statistical domain, consolidated banking statistics. You will see whether they are mandatory or optional. That's the M at the beginning. You will see the role played by this component. Are these dimensions or measures or attributes? And if it's an attributes, are which level are they attached? And for each of these components, you will have additional information, such as their data type, like a string, or any additional characteristics or facets attached to it, like length, for example. So if we take the frequency in this case, we see that it must be a character, a string, so of exactly 1 character length, and it must come from the frequency code list where we have these 8 codes defined. And these types of metadata are typically used for data validation, but they can also be used to create the physical data models, such as, for example, data tables in a database. Another type of very useful metadata are the so-called provisioning metadata. And maybe some of us are not familiar with this term, but provisioning metadata basically is about who sends what, to whom, and when. So that's this type of metadata. So this is where you will see the different flows of data, known as data flows in SDMX. You will also have information about who are the organizations providing data, so the data providers, any release calendar. So this is the type of information. But you can also set additional constraints to it to make the validation more granular. So let's give an example. Again, continuing with the consolidated banking statistics. We see here, for example, that in the context of this particular data flow for the frequency, we expect only quarterly data. So there is an additional constraints that have been set on the frequency. Now, it's not the only place where you can put such constraints. You can also associate them with data providers. For example, if we have a look at the reporting countries, we see that one of these 35 entries is allowed. But if we take, let's say, National Bank of Belgium, then we see that the only code allowed is Belgium. So these types of metadata are, again, very useful for validation purposes, but they can also be used to build, for example, data collection services or timeliness reports. That's the type of metadata you need for these. There are many other types of metadata that you have access to in the registry, such as, for example, hierarchies, the metadata you need to validate or transform using the VTL. You have mapping metadata. So you have a lot of additional metadata available, but I think we should stop here because it's not a webinar about SDMX metadata or the FMR. And I think with the information I've just given, there is enough to make sense of the demo afterwards. So let's go to the Python code. And this use case here, as you can see, with the Python code, it's fairly simple. So there is not a lot of code. it's a simple use case, but it's a use case that I think many of us have had to face anyway. And it's also a use case that allows us maybe to show how a lot of the SDMX complexity is hidden behind the Python API that we offer. And this use case is we have the metadata defined in the registry, the structural metadata, and we want to use it to create a table in a relational database, like, for example, SQL Server. So fairly easy use case, but like I said, fairly common as well. So for this, what you will need first is to instantiate a registry client. And to instantiate a registry client, the only mandatory parameter is the SDMX REST endpoint from which we need to fetch metadata, which for the FMR sandbox is this one. In this case, I have also a second parameter, which is the so-called PEM file. This is optional, and whether you need it or not will depend on your environment. In this case, I need it because I'm executing this code from the BIS network. And if I was not doing this, if I was not passing that, I would get SSL certificate errors. To avoid this, I pass this PEM file where I have indicated that the BIS is a trusted certificate authority. And this then takes care of the SSL errors that would occur otherwise. If you are outside and you are connecting, for example, to the global registry, you will not need that. So it depends a bit on from where you execute the code. But if you happen to have SSL errors when you execute a metadata query against the client, then it's most likely that you will need to do something similar. In case you face that and don't know how to solve this, then please just open a discussion point in the forums that I showed previously on the GitHub repository. And I will try to answer as quickly as possible. Another thing that is interesting to know for the registry client is that in this case, I'm using the class called registry client, which is a good default one. If you need to execute, if you, sorry, Brian, are you seeing a black screen or?
Everything's fine, Zach. It's just a warning for people in case they are having issues because it's happened in other webinars.
Oh, okay. I'm sorry. Then let me go on. Sorry. Yes. So the other type of so this registry client allows us to have synchronous calls to the registry, and this is a good use case. For example, if you need to execute the call sequentially. Now there might be cases where you want to execute calls in parallel. For example, if you build a metadata cache and you want it to be built faster. Or maybe you are using a framework like the Fast API, which in its nature is asynchronous. In that case, you can use the async registry client. They both behave the same. So they will expose the same API, but one is to be used in a synchronous mode and the other one is to be used in an asynchronous mode. And then once you have a client, you will see that we have different GET functions to retrieve metadata from a registry. Now, to support this use case, we can choose between two types of resources, schema or data flow details. Both will offer the same core information, so they will give you the list of components that are relevant in the context that you supply, so which data flow, for example. But the data flow details is more suited for data discovery because it offers you additional information, such as, for example, the list of data providers or the number of observations or time series and this type of information. We don't need this to build a database table, so we will simply take the get schema. So let me get rid of this. And you see here, I'm just calling get schema, and a schema can be created for 3 different contexts: data flow, data structure, or provision agreement. In this case, I'm taking the data flow. And then we pass information about the maintenance agency, the ID, and the version, and we should get the schema. So I will execute this in debug mode so that we can have a look at the object together. So code has started. And you see we get a schema. And the schema has the usual information that you can find in SDMX, with like the agency, the ID, and the version.
But in this case, what we're interested in really is the list of components. And this is one first example of how I think the library is Pythonic. For example, you see these components is basically a Python list. So it will behave like any Python list in your Python code. So we have used the Python native data structures to represent SDMX artifacts. So that's one way where I think this is Pythonic. And this is why, because it's actually a Python list, this is why you have here this data property. Now we have added other properties with the hope that they make things easy for you, like you have filters on the component role to get the attributes, the dimensions, or the measures from the main list. And then when you iterate over the various components, like here, let's take the first one, you will have the usual information you expect again from SDMX, like the ID, the name, but basically everything that is relevant within the context of this dimension is easily accessible using Python properties. For example, you remember maybe that the frequency code list, that the frequency concept dimension is using a code list. And here you see it in the enumeration. We have that code list object over there. But you remember maybe that there was a constraint applied to it. And in the context of this data flow, only quarterly was relevant. So we have only one code there. It's the quarterly value. But for this code, we have all the information, like not only the code itself, but also its name. And if there was a description associated, it would be there as well. So it's the full object. We have additional information there as well. For example, let me get out. So enumeration. So we have the data type. We have the list, in this case, a string. We have the list of facets that have been defined. And in this case, it was, if you remember, minimum length and max length. The rest was set to none. So everything that is relevant for this context is provided there in the form of Python attributes. And this hides a lot of the complexity of SDMX because there is actually quite a lot going on behind the scene. You have the data structure. You have the data flow that references the data structure. The data structure references the code list and the concept schemes. There are constraints associated maybe to the data structure or maybe to the data flow that needs to be applied. These constraints can be defined as either cube regions or key sets. They might be inclusive or they're exclusive. For the type itself or the facets, they could be associated with the concept in the data structure or with the concept in the concept scheme. And if that's the case, you need to take the local ones, so the concept associated with the DSD. If it's not, then you need to take it from the concept scheme. So you need basically to be an SDMX expert to make sense of all this information. And here we have hidden all this complexity using native Python data structures and providing all information about the context in one single place, already pre-processed for you. So now that we have had a look at this object, and we can have a look at what we need to do. And in this case, it's create a SQL statement to create a table. For the table itself, we will simply use the data flow ID. And then for the columns, we will iterate over the components. For the column name, we'll take the component ID. For the type, I will show you the function later, but basically we are using the data type and the facets to derive the SQL type. To get whether a column is nullable, we use the component required property. And then we also need to build a primary key. And for this, it's easy. We simply build a composite primary key based on the dimensions IDs. And that's all we need to do. So let's go to this infer SQL type. Of course, this function here is not meant to be production ready. It's also a subset of the types that we need to care about, but it's what I needed for this little demo. But it gives you an ID, right? You can use the type to map to SQL types, like for example, integer in SDMX maps to an int, in this case in SQL Server. And there are some more interesting cases. For example, if it's a string, we can also have a look at the facets. Because if it has facets, like for min length and max length, and the value is the same, then we can define a column with a fixed number of characters set to max length. However, if that's not the case and there is a max length, then we can create a column of variable size, but of a maximum length set by the max length property. So you see, it's fairly easy to map it to the SQL code. And so this is what we see here. So now let's execute until the end. And if I increase this a bit, you see we have created basically the statement that could now be executed using something, for example, like PyODBC. And we have all the columns, their types, their information, whether they are nullable, and we have built the primary key based on the combined dimension values. So I think this is, although it's a very simple example, it's nevertheless a use case that is quite common. I think many of us had to go through this. And I hope I showed you how pysdmx can help with that by providing Pythonic API that simplifies a bit and lower basically the barrier of entry to SDMX. So that's it on my side. And I will now pass over to Javier for the demo around data handling. Thank you very much.
Thank you, Xavier. Well, good morning, everyone. My name is Javier Hernandez, and yes, I will focus more on the data side on SDMX and the use of pysdmx regarding data and how we can use this library and some other Python. I believe in getting muted automatically. Okay. How we can use the tools, the open source tools based on Python and Fusion metadata registry to ensure that we can make a statistical process to get from raw data, from tabular data to SDMX inside an SDMX driven organization. I will now share my screen. Let me know if you can see it. Yes, okay, thanks. So to state the problem, we are trying to focus on a world that everything on an SDMX-driven organization has its metadata already defined, its data already defined, in an structured way, as we can show. But there is a huge world of data, of raw data, of tabular data that we may use to convert it to SDMX data and to generate aggregated statistics over it. We will focus today on a problem that comes with on a very specific use case that some organizations may want to use the legal entity identifiers that are maintained by the Global Legal Entity Identifiers Foundation, and to enhance their master data whenever they try to produce the data. The legal entity identifiers, for those who don't know, is a standard identifier that is unique in the world and shows the information of a particular company and its subsidiaries, and holds this identifier, which is a 20-character string. And of course, it holds some information about the company, like, for example, the legal address, the country of incorporation, and some other data. We'll see into it. For today's use case, we'll show a nestalized statistical process. We'll try to convert this raw data that is maintained by the Global Legal Entity Identifier Foundation to convert it into SDMX and use pysdmx in order to generate these datasets, validate these datasets using the Fusion metadata registry, validate as well the data itself using PTL, make aggregated statistics using the PTL language, and finally disseminate the data by generating an SDMX ML file. For the first step of the process, we'll try to collect the data. So let's focus now on the data that the Global Legal Entity Identifier Foundation provides. We picked up a what they call the golden copy. The golden copy is at a specific point of time, the total amount of legal entity identifiers that this organization holds, and it holds some information like the entity legal name, for example, the names that it could be called, this company, the country, and whatever. As you can see, this is a very big data. We are only focusing on as a sample data on the first 10,000 rows, but as you can see, it has 338 columns, which is a lot. As well, you will find that some of the column names are not very similar than what we are used in the SDMX world. So we'll need to make some data cleanup and data formatting in order to ensure that we are able to handle this data correctly, and of course generating the data structures and Fusion metadata registry and perform all the SDMX driven process. For the data cleanup, we'll use only pandas, and on pandas we'll rename some of the columns and keep them. For example, the entity legal name, the entity legal address, and well, the country of incorporation, which is present in this column, and another data like, for example, the postal code, which we will use later on to make some validation for this use case, to showcase the usefulness of BTL as a business-friendly language in order to perform these validations. We'll also filter the data by the status as active. We do only want to get all the legal entity identifiers that are currently active. So for the 10,000 rows that we had initially, now we focus only on 9,500 rows with only 8 columns. So we have decreased the data quite a bit. On a second step, once we have prepared the data, we can generate a pysdmx dataset object, focusing at the very moment on the pandas dataset object. This is a dataset, an SDMX dataset that holds data using the pandas library, which is widely used by many data scientists in order to transform the data, and it has a really nice API. So we thought that the very first use case to show how to handle data with SDM inside the pysdmx library should be based on pandas, as I said, it's one of the most widely used. So now we'll follow mostly the same process that Xavier showed before. We just get the client, use the registry client in order to query a Fusion metadata registry instance in order to download the schema. In this case, instead of using a data flow, we are going to use a data structure, as you can see here. The format we will use today is the Fusion JSON custom format, which is a custom format that is bound to the Fusion metadata registry. We have it defined, and here in our own instance at meaningful data of the Fusion metadata registry, if we see the data structure definition, we found that we have only one dimension, which will be the legal entity identifier, some measures, which will be, for example, the postal code, the country of incorporation, which is enumerated. It is based on the CL area. For example, some attributes only on the legal name. We can, of course, tailor as good as we can this data, but for this use case, we thought that this was the best setup for the intent that we wanted to make. Now we will be able to generate the pandas dataset, and as we can see, we have this what we call the short URN. The short URN is what we call the meaningful part of the URN of this object. It is made by combining the SDMX type, which in this case is a data structure definition, data structure. Secondly, we will have the agency, ND, as in meaningful data, the ID, as in LEI data, and the version 1.0. With this information, we will be able to just find the specific data that we want and to identify it uniquely. Continuing with Fusion metadata registry, we will now perform the structural validation of this data. So once we combine it into a pandas dataset, this object that is inside pysdmx will make a custom function in order to validate the data by querying Fusion Metadata Registry and downloading the list of errors that we found based on the data structure definition that we have provided. So as we can find, there is no error. This functionality can be also used in the user interface by selecting the convert data functionality inside the Fusion Metadata Registry. Now that we know that the data is structurally validated in SDMX, that the code lists are completely prepared, for example, the country of incorporation or the headquarters country is now present inside the CL area code list. So we were trying to match, for example, the ISO codes of these countries and to be present in this code list. But validating using SDMX many times won't be enough because we can only perform structural validation. But what if we want to make additional validations? For example, we want to perform validations based on two components of the data. For it, we'll use then a small validation script that it will focus on the postal codes that we may find in the postal codes. There are some regular expressions bound to each of the countries. So if we see the code here in Python, we'll see that they will be. For example, let's go to find Spain, which is ES on the ISO code. Here we have it. We have a postal code that is only 5 numbers. Okay, so we will need to match this regular expression and have it. Okay, you will still see the browser. Okay, let me check. I guess you can see it now. Okay. So in this rule, using BTL, we find out that for the country Spain, which ISO code ES, we now have 5 numbers as the postal code. For example, in Salamanca, which is my city, is 3700. Sorry, 37,000. So it will be 37,001, 37,002, but we may continue. By validating this data, we ensure that the data has good quality. The Global Legal Entity Foundation has a lot of data quality checks, which we won't be diving today because we wanted just to showcase how using BTL and a business-friendly language, we can perform validation outside the SDMX. We won't be able to dive into the actual definition of the language on BTL and this language because we do want as well to make a webinar based only on BTL. So we'll try to set it up in the near future and contact you for more specific questions regarding BTL. For today, we'll just focus on one specific thing, which will be to use the BTL engine library, which we also maintain, in combination with the pysdmx library to perform this kind of validations. First of all, then, we'll load the script and run the BTL validations. Once we are running the BTL validations, then we can see the total number of errors that we are finding. We set it up this use case in order to validate data with two different kinds of errors. Error level 3, it will be given in this use case with a severity of error, or not critical error, but a big error, a sufficient error that we found that this data is invalid completely. And error level 1 will find this data that it has only some warnings, maybe, or some small errors that are not severe enough to discriminate this data and remove it. For example, for a data producer, it will be very useful to be able to discriminate the data based on the severity of the errors that we are finding. So to get only the valid data and adhering to the guidelines that the data producers has for this specific data. We'll then analyze the errors on the postal codes, and as we can find, some errors, for example, for the country is Bulgaria, which has only 4 numbers in their postal code, but we find that some of the some of the data has a space in between the third and the fourth zero. So this would be should be considered as an error. In fact, the Global Legal Entity Identifier Foundation has this in their data quality checks, but somehow they are not really analyzing at least the postal code as much as we could find. So I believe this data should be wrong. Therefore, we should filter now the data and remove those legal entity identifiers that we, from the sample that we had before, that they are completely wrong. Now we have only remaining 9,500 rows of this data, which we'll find here. And all of these rows will be valid data from this sample. So as I'm saying, we are using BTL in order to discriminate the data based on the severity of the errors that we are using, which I believe it will be very useful for any data producer. But BTL is not only a validation language, it is also a transformation language. So we can use BTL to perform some calculations and to perform aggregated statistics based on the BTL language and a small set of rules. As they are business friendly, they could be also disseminated and given to the actual users in order to ensure that the data that the process is shown on how this data has been generated, which is the original data, how we transform it, and how we generate this calculation. A typical example for it, I would like to showcase it using our own BTL playground, which is part as well as the BTL engine of our BTL suite. We may find here that for this BTL script, we have an original data, which is called LEI data, which is the same data structure that we had before, just converted to the BTL format. Later on, we have some amount of transformations, for example, to get as an identifier as the country of incorporation and the country of the headquarters. These columns are based on the country where the company has been incorporated. And the country of headquarters is the country where the headquarters are located. So they might be different based on and they may give you, for some companies, they would prefer to have it to be incorporated in a different country that the headquarters are present itself. So we generate them by performing some aggregations, mainly using the count operator and also some renames, maybe generating some dimensions based on the actual data. And finally, we'll join all this data into a specific data set that is called LEI statistics. Okay. Coming back to the notebook, we'll load now all of the golden copy of all of the legal entity identifiers that we are using, okay, that they are at a specific point of time. So now, instead of using just a sample of 10,000 rows, now we are using 2.5 million rows. And this is running in my laptop. As you can see, it is localhost on the URL, so it's no, you can use it on any laptop or on any computer. These libraries are intended to be as efficient as possible in order to adhere to these kind of use cases. Now we have been loaded all the data. We can find now that they are 2.6 million rows, just 8 columns. And now we perform the BTL calculations. It will take just about 10 seconds, more or less. Once we have generated all these aggregated statistics, we can show it, and that we'll find some data where it could show for each country how many number of incorporated entities it has, how many number of different entities which their headquarters are present in this country, and how many countries have some entities with a different headquarters than the country of incorporation. Okay. To show this aggregated data in a just a small diagram, we find for better understanding and for a data analyst that will perform as well this analysis using these aggregated statistics, we find that the countries with the most legal entity identifiers are the Cayman Islands, Virgin Islands, and Luxembourg. As you can see, this is all made using pysdmx and BTL engine. We are not only using pysdmx for SDMX data, but we may as well use pysdmx for any kind of data, transform it into SDMX-based statistics, and later on use BTL to perform any kind of validation that we may want, as long as it is feasible using the business-friendly BTL language in order to disseminate later on the rules that we wanted to perform. Finally, with the aggregated data, we may use the pysdmx library again to generate another pandas dataset with the aggregated data. We just run this code, and this is now based on on a very specific function that I do really like, because it's only called read SDMX. Inside this function, you may use any kind of string, you may use an URL, you may use a file, you may use whatever you need with any kind of SDMX format that we currently support. You just set it up in a way that you call this function to read the data, and then you will retrieve a message. A message is a specific kind of class where we can actually get, for example, the structures that we may want to use. Just similar to the pysdmx API that Xavier shown before, with the schema and with the registry client in order to retrieve all the information from a Fusion metadata registry, for example. We can as well retrieve it from a specific SDMX message. So in this place, we use the method getDataStructureDefinition to download it. And later on, we generate the dataset using this schema. We convert the data structure definition object to a schema as we require it to have it on pandas dataset, and later on we display the data. Okay. Finally, getting all this data aggregated, now we want to write the SDMX ML 2.1 file for dissemination. Maybe as a data producer, we do have a data portal where the users want to have this data. So this data is currently present, for example, maybe present in a database, maybe present in a set of files, however we want. We can just convert it to a pandas data frame and later on run it in order to write an XML file using for example, the specific writer on SDMX 2.1 structure specific, and we can now have all the list of observations that we may want. I believe this is quite useful as well for a data producer in order to ensure that their clients, or maybe the citizens, if it is a national statistical organization, in order to retrieve the data as fast as they can using only just a couple of lines of code, and it is quite easy to integrate it inside any kind of SDMX API as long as it is based in Python. As Xavier suggested, we could use, for example, here some libraries like Fast API, maybe Flask, maybe Django, maybe this kind of libraries to generate an SDMX API product. With all this, that's all from my side. I would like as well to thank you for your time. I hope I hope this use case will foster you to use pysdmx and BTL engine inside your use cases and your data producer use cases. And I would like as well to acknowledge the team, which is also watching us, for helping me and helping us in the development of the pysdmx library, the BTL engine library, back here at Meaningful Data. And yes, of course, we'll share the Jupyter Notebook file, not this particular version, but the version that has all this explanation that I have made, just written in text. It's for better understanding of all the function. Yes. Thanks so much for your time.
So, Xavier, we have time now for questions. Either raise your hand or post your questions in the chat, please. I think that you guys have clearly demonstrated the power of BIS, SDMX, and BTL, and I think it's eye-opening and overwhelming at the same time. So we'll see if people need to reflect on this a little bit before being able to pose questions.
Excuse me. Good day. Can you hear me?
Yes, please go ahead.
Hi there, this is me. I'm Modestas from Bank of Lithuania, Lietuvos Bankas, and I would like to, well, it's hard to catch everything throughout one presentation, but to feel what is in the depths of SDMX library. As I got it, you used it on casual data to make it SDMX alike, and from SDMX to casual data format. And the question is, do you use pysdmx also to create, like, how do I say it, architectural, like, to create SDMX based tables in your database? You do that as well?
Well, as long yes, you may use it, but just following, for example, the pandas use case. So maybe you can have a pandas data frame and then save the data inside that table. So in pandas, you will have the list of the columns with a data type, for example, string, integer, whatever you need, and then later on save it into your database. This is quite used in the data science world. In order to make it SDMX driven, you will need as well to define the metadata using the process that Xavier followed, or maybe using Fusion Metadata Registry to have it stored there, or these kind of tools in order to store there the metadata and then later on try to validate the data that you have already saved using the metadata that you have already generated. Xavier, I don't know if you want to comment.
Yeah, maybe one thing on our side, because on our side the answer is a clear yes. So the example I was mentioning of the data lakehouse that we have is basically powered by Python, and we have different steps. Like, so we collect data, we archive this data, we normalize them, and by normalization we mean data validation, data mapping, these kind of things, or data consolidation. And then we integrate this data by putting them in context of what was previously received from the same providers. And each of these steps are 100% metadata driven. And all the metadata, absolutely all of them, are in the registry, including the configuration options, for example, for validation or mapping. So the entire architecture, as you were mentioning, is basically SDMX driven.
Would you offer to use just Fusion Registry and pysdmx? You can, as I get it, you can get around just with those two, and of course pandas, etc.
Yes, there is still one thing, is that so these business functions that I was mentioning, like for example that data validation or data mapping, they are on the pysdmx roadmap, but they are not part of the source code yet that you will find. And the reason for this is that this is so an implementation for a BIS system, and so there are things that might be BIS specific. Every organization has a kind of opinionated view on how SDMX should work. So there are things that are probably too opinionated to be open sourced at the moment, but it's on the roadmap. It will just take a while.
Thank you very much, and can't wait to get a grip on the, showcased Python files. Thank you.
Thanks a lot, Modestas. And I see that there are also some questions in the chat that have been answered. So thanks for those as well. Any other questions?
I've got a question. Actually, I've got two questions. I'm Benoit, working in Luxembourg as a consultant for a major public administration here, using, of course, FMR and SDMX. So first of all, thank you both for this presentation. It's really useful. And actually, I've got a question, maybe first to Javier. Since the VTL topic is also in my to-do list for the learn and practice, I wanted to know if the in the demo, you presented the VTL codes that you refer to can be also developed within FMR, and whether SDMX will pick up VTL codes from FMR to further execute it.
Well, unfortunately, I'm not that part of the FMR team, so I will leave that part of the question for them. Xavier, maybe Brian. As far as I know, you cannot execute or semantically validate data using VTL inside the FMR, but I will let them to answer this.
Brian, I don't know the answer either, but I see that Stratos is on the call and maybe he knows.
Yeah, I saw him as well. We have a point together with Stratos. Yeah.
Go ahead, Stratus.
Apparently he just left. Oops.
Okay.
Ah, he's back. He's back. He's back.
Yeah.
Stratos, can you hear us?
Yeah, probably you can hear me now.
Yeah.
Yes.
I don't know
yes.
if you can see me. I don't know if, yeah.
Yes, we can.
Okay, great. So thanks a lot. Yes. Now, VTL and FMR, there are a few things there, and I would try to be relatively quick. First of all, yes, we can store VTL rules in the FMR. I think on the pysdmx side, yes, we can retrieve rules, if I'm not completely wrong, as metadata, but the FMR per se cannot execute rules for now. Now, we have been working with different VTL engine providers, and one of them is meaningful data. We are in some cases we have established a collaboration already. In others, we're just starting, and the idea is to establish different ways of integration, if I may call it. So, in some cases, the simplest ways, for example, you have a VTL engine, you get the VTL rules. I think it's pretty much what Javier was illustrating, and then you can execute it with an external engine. In the future, we are also planning to see how we can streamline a bit the VTL validation within the FMR, since you have the rules and all the related metadata when it comes to SDMX data. This is not yet implemented, but I think it's in the roadmap, and it's something that will come eventually, also depending on the interest of the FMR users, I guess.
Okay, thank you.
Thank you.
Thanks, Stratus. Yuri, you have your hand raised?
Yeah, I have a couple of questions to Xavier with respect to the way this kind of data flow object is being created in Python. So I see that it's very Pythonic, the object that we receive, but is there a way to reverse the process for example, let's assume we take the data flow from one repository, and we would like to then, from the Python code, send it somewhere else or send parts of it somewhere else. Once it has assembled, let's say, all the enumerations that it needs for the code list, is it possible to, or does it keep a trace of what kind of artifacts were at the origin, and can it rewrite these artifacts, or it's just
yeah, thanks for the question. No, at the moment this is not possible. So it's the focus was on retrieving metadata, let's say, in an easy way, in an intuitive way, but it's on the roadmap, because so one of the things we need to work on is to be able to use pysdmx to maintain metadata in a registry to support the type of use cases that you were mentioning. And so from this context, we will need to have functions that allow us to go from the pysdmx objects to the SDMX artifacts. So this is coming. Yeah.
Okay. And the other question I had is related to, I mean, how heavy you think is the creation of this kind of data flow objects? So do you have to send out multiple messages to the registry in order to actually build the dataset object, or it's kind of you have a very kind of light call on the registry? I mean, my question is motivated from the fact that we see that sometimes to have a data set as rich and well annotated as your data flow object, we have to have a very elaborate multi-query strategy, which can be heavy on the registry if many users in parallel mode request many data flows and data sets that way.
Yeah, at the moment, so if you have a client and you see the different GET methods that were exposed by the client, most of them will be answered with one query and one query only. Now, I don't remember which one, but there is one or two, not more. I think it's one. And I think it's the get data flow info where we needed two queries.
Okay.
But there is one or two, not more, and it's only two queries. It's not beyond that. We are not talking about 3, 4, 5 queries. Definitely not.
Okay. Thanks.
Thanks, Yuri. There's another question from pardon me for the pronunciation.
For the presentation, the part about the writing SDMX is exactly the part that has been something I've been waiting for a long time. So thank you for that. I'm just following up my question that I sent in the chat. Essentially, when I looked at how you are importing the library for writing SDMX, the path is very specific. My question was more related to, could we design the method in such a way that it's kind of like future proof? Like if somebody's calling it, let's say they don't want to actually supply an SDMX version, they could just supply the data set, and depending on what SDMX is currently supported, then that SDMX is what is going to be produced. So like it just comes down to future proofing the solution, so that maybe people that use it don't have to worry about but like if they want an older version, they can supply it. But if there's a currently supported one, we produce the currently supported one.
Yes, so the main problem that we face, and that's something that we still need to discuss, is that it is quite easy to make a general method for reading, okay, like read SDMX, because inside the SDMX message you have already the format. The problem with the general method for writing is that you need to specify the format, and not only the format, you need to make the signature so to write data messages and structure messages. Okay. The main problem that we found is that we run out of time in order to make a proper proposal to make this method. We'll try to include it in the roadmap, which, by the way, I've seen also some questions about because I believe we haven't shown it on the screen due to the issue that we had before. So yeah, but we will try to include it in the roadmap, but it is something that is still needs to discuss. We do want and we do really want to make sure that we don't make any backward compatibility breaking on future versions of pysdmx. So if we release a specific method, we want that specific method has the same signature in all the releases that we'll make from now in the future. If we need to change a specific method, then we'll make a major release, like a 2.0 release or something like that.
Great. Thank you. That's a great answer. And yeah, no, thank you. This is a great effort. I look forward to trying it out.
Brian, I believe you're muted.
Thank you for the question. Thanks, Cynthia. I don't know if you guys want to address the question in the chat about the roadmap.
Yes, I can maybe share my screen again because I had forgotten to do it. at the beginning. So yes, so many of the items that basically the items that we intend to cover in the next 2 releases that we are aware of, at least at the moment, are captured here on the list of issues. And there you can see also the next 2 milestones and which issues we intend to cover in these next milestones. Now, it's not the entire roadmap because there are other things that we are considering. For example, like I was mentioning, the kind of business functions like data validation, data mapping, or data consolidation. And these are not yet part of the roadmap. So it's a work in progress. It needs to be extended a bit. But for the time being, I guess that's the best that we can offer at the moment. It's this list of issues and how they are organized in milestones. And we also commit to try and capture the remaining issues as soon as possible.
Okay. Thanks for the question. Thanks for the answer, Xavier. Time for one more question. Going once. Going twice.
Yeah, can I ask something?
Please go ahead.
Oh no, if you can see me, probably not.
We can hear you.
So I have this question. I've been interested in SDMX for like, let's say half a year. I was using the library for like reading SDMX messages. And I was wondering if like this library has a functionality where I can build like my own SDMX artifacts, like data structures or anything, just to build like a whole message.
Okay, this one then? Yes, absolutely you can. The only thing is that we do have it now in the roadmap, maybe to upload it or to make easier to upload it to Fusion Metadata Registry, for example, and these kind of tools. But as of today, you can of course generate all the objects. This will be Python classes based on the message spec library, so you will be able to serialize them on JSON on several formats, and as well you will be able to write them currently in SDMXML 2.1 using the dedicated writer. And I believe that that's not currently in the documentation on a specific tutorial about that, because we're waiting for for some integration of a couple of functionalities, but for sure it will be in the tutorial as a brief introduction and as a nice tutorial on how to generate your own objects and writing later on to SDMXML 2.1. Currently, you will have it now available in the documentation how to generate your metadata model. So just follow the tutorials and try to adhere to your specific use case for it.
Okay, thank you so much.
No problem.
So that's all the time that we have. Thanks, Javier. Thanks, Xavier. And thanks, everybody, for your participation. We look very much forward to the evolution of pysdmx and VTL. It's really exciting. And future webinars to help inform everybody about the developments. Thanks, and have a great day, everybody.
Thank you.
Thank
Have
you.
a nice day.
Thanks, everyone. Bye.